Hi, in this video, we will explore CSTEP's Transmission Visualization Portal for South India. The electricity that we use in our homes, offices, shops, factories, and laboratories comes from a large number of specialized generating stations that are spread across the country and are based on various technologies. These generating stations are interconnected via a network of transmission lines that crisscross the nation and substations that convert power into different voltage levels. India's power system is split into 5 regions: the northern, western, eastern, northeastern, and southern regions. The southern region, covering the states of Karnataka, Tamil Nadu, Andhra Pradesh, Telangana, Kerala, and the Union Territory of Puducherry, has the highest potential and deployment of renewable energy in India. CSTEP's Transmission Visualization Portal is an attempt to present this complex power system network in a visual and geospatial form, giving experts and laypeople an easy and powerful avenue to understand the intricacies of the network. We hope this portal can become a unique aid to power system operators, climate and power system researchers, students, teachers, policymakers, consultants, and other industry stakeholders. India has set ambitious renewable energy targets for the next decade. The portal is the outcome of an effort to study the grid impact of high renewable energy scenarios in South India in 2022 and 2030. It is a web application that can be accessed on any modern browser at http://darpan.cstep.in/high-re/. Detailed information about the features of the portal will be added soon. But for the time being, let's take a brief look at some of its salient features. Let's start off with the visual interface of the portal. Right at the top of the screen is the option to select the year 2022 or 2030. Selecting the year is crucial as all the information in the portal is based on this selection. Just below the Select Year button, there are 3 tabs that the portal offers: the Data Layers tab, which shows us the generation infrastructure; the Explore Grid tab, which shows us the transmission infrastructure; and the Scenarios tab, which shows us power flow simulation outputs for both generation and transmission. Let's explore these tabs further. Selecting the Data Layers tab lets us visualize all the different generating stations in the region. It gives us options to see the base layer with or without district boundaries and physical terrain. Below the base layer are the overlays with a list of different types of generating stations. Each type of generating station can be displayed on the map or hidden by selecting or clearing the checkbox next to it. For example, we can see the spread of solar plants or wind plants throughout the region by selecting the respective checkboxes. We can also examine any particular plant displayed on the map by clicking on it. This shows us important information about the plant, such as the capacity and the developer name. Clicking on a plant also displays the transmission station through which the plant exports its power. Similarly, we can see information on coal-based thermal plants. Again, we can click on any of the plants to see more information. Here we can see the number of units and their capacity. As you can see, the portal encompasses the generation infrastructure across South India. The last 2 entries in this tab help us visualize potential land parcels for wind and solar plants which are proposed by CSTEP and could be taken up for deployment. The details of these land parcels, including the connected substation, can be seen by clicking on them. Let's now move on to the transmission aspect. The Explore Grid tab allows us to view the transmission network elements in the region. We start by deciding whether we want to view substations, transmission lines, or both. We then select the nominal voltage of the network elements we want to see and click on the Load button. Upon selecting substations and 400 kV, we can see the substations of the 400 kV level in the transmission network. Clicking on any substation shows its name and the number of transformers it has and their capacity. It also shows the voltages that this substation deals with. Similarly, we can view transmission lines. Clicking on the lines shows us the substations the lines connect, their length, and their transmission capacity, as well as number of circuits. Now, let's look at the scenarios tab. This tab allows us to see a simulation of the state of the grid at specific points in time. For example, to see how the grid behaves at peak solar condition, loading this scenario allows us to see both conventional generation and transmission with the current state of each element in this condition. At a glance, we can see the overall balance of load and generation at this point in time. Clicking on a substation shows its name and the number of transformers it has and their capacity. Likewise, clicking on a transmission line shows us the amount of power, both active and reactive, flowing through the line. If the substation happens to be a generating station, the amount of generation being generated at that station is also visible. This was a brief overview of the Transmission Visualization portal for the southern region. You can explore this platform freely, examining hundreds of different transmission and generation elements in detail. To know more about the data sources, assumptions, or other aspects, head over to read our report on how the data for this portal were obtained and simulated. For any queries on this portal or on the study, we would be glad to hear from you. Thank you.